Operations on complex number. Part 2. Now, equality of two complex numbers, let Z1 and Z2 belongs to the set of complex number such that Z1 is equal to A plus IB and Z2 is equal to C plus ID. So here, real Z1 is A and real Z2 is C. Imaginary Z1 is B and imaginary Z2 is D. Now, two complex numbers Z1 and Z2 are said to be equal if real Z1 is equals to real Z2 and imaginary Z1 is equals to imaginary Z2. That is, A is equals to C and B is equals to D. Now we'll set up an example here. It's 2x plus I. X minus 3I is equals to 2 plus 5I. 6 plus 5I. Now these two complex number 2x plus I into x minus 3y and right hand side is 6 plus 5y and they are equal. So now we are able to find the value of x and y. 3y. Find the values of x and y. So here real part is 2x and here the real part is z. So 2x equals to 6 because these two sets are equal. So real z1 is equal to real z2 and x minus 3y is equal to 5. Now from this equation we obtain x is equals to 3. And when you put x is equal to 3 here, we are getting 3 minus 3y is equal to 5. So minus 3y is equal to 5 minus 3. So this implies y equals to 5 minus 3 is 2, y minus 3. So value of x and y obtained, hence x is equals to 3 and y is equals to minus 2 by 3. Now additive inverse of a complex number z is equals to a plus ib. Z is equals to a plus ib. And if you introduce minus z is equals to minus a minus ib. Now if you add z plus minus z, we obtain a plus ib, then then minus A minus IB. Now A minus A then B minus B. A minus A is 0 and 0 is the additive identity, hence minus Z is the additive inverse of Z. Now we want to find the multiplicative inverse of a complex number Z is equal to A plus IB. As you know, Z into 1 by Z is equals to 1. Then 1 by Z, it can be written as Z to the power minus 1 is the multiplicative inverse of Z. Now, when Z is given, how you will get the multiplicative inverse of Z? Now, Z is equal to A plus IB. Then, Z inverse is equals to 1 by Z. Equals to 1 by A plus IB. Now, if you multiply this with A minus IB, this A minus IB is the conjugate of A plus IB. So, when you multiply A plus IB with A minus IB, we obtain A square minus IB whole square, and it becomes A square plus B square. So here it's coming denominator A square plus B square. Numerator. Now if we separate these two, you obtain the real part. Imaginary part. Minus B. And this is in the form A plus IB belongs to set of complex numbers. Now we'll find the multiplicative inverse of 5 minus 3i, and second is 5 minus 3i by 3 plus 2i. So first one, this is our Z. So 5 minus 3i. Now multiply this. 5 plus 3i, which is equals to 5 plus 3i, product of these two, 5 square minus 3i whole square, 25 minus 9 is equals to 16. Sorry, 34. So 5 by 34, real part, 3 by 34, imaginary part. So Z inverse is equals to multiply inverse of in fact, thirty-four is a whole square and this is Z and its conjugate Z. Multiply inverse of 5 minus 3i by 3 plus 2i. This is 1 by Z, so you can write 3 plus 2i, 5 minus 3i, and multiplied with 5 plus 3i. Now, denominator becomes 5 square plus 3 square, that is 34, 25 plus 9. So 3 is multiplied with these 2. Here, when distributive law, we are getting here 5 plus 3i 34. Now 3 plus 5, 15. 3 is a 9i. 2 5 is a 10. Minus 6. 15 minus 6. 9 plus 10. 15 minus 6 is equals to 9 by 34. 19 by 34. So this is the multiplicative inverse of 5 minus 3i upon 3 plus 2i. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.